Alright guys, now we're moving on to lesson 5, chapter 5, and this chapter is really big for the keystone stuff, so there's a lot of formulas in here that you're really going to need to memorize, so make sure if you don't understand anything in this whole chapter, it's just going to keep building and building until it's this like giant snowball, so make sure that you understand the stuff and practice the stuff as we go along, because chapter 5 is pretty tough. So the objectives just for this lesson, we need to find the rates of change from a table and try and find slope. And you maybe did a little bit of slope last year in pre-algebra. We'll see how much you remember. Okay, so the vocabulary here to start us off is rate of change. It's pretty much exactly what it's saying. The rate of change is showing how much something is changing. Shows the relationship, and that's spelled wrong, but spell it right in your notes. Shows the relationship between two changing quantities. So think of like height in time or distance in time, something like that. It's going to show the relationship between how the two quantities are changing. So we've already learned independent and dependent variables. So when one quality depends on the other, you can figure out the rate of change, and this is just one of the many formulas we need to memorize. Rate of change is the change in the dependent variable divided by, because this is a fraction, change in the independent variable. Okay, so definitely write that formula down. Rate of change equals change in the dependent variable divided by change in the independent variable. And I put here y and x because that's going to help you. The dependent variable is always on the y-axis and independent is always on the x. And when we start doing this from a graph, it's going to help just for you to realize the y values are always on the top and the x values are always on the bottom. Okay, so problem 1 here, it says, it's about a marching band. It says the table shows the distance a band marches over time. Is the rate of change in distance with respect to time constant? What does the rate of change represent? So to figure out if the rate of change is constant, after 1 minute, they've gone 260 feet. After 2 minutes, they've gone 520, and so on. So to figure out the rate of change in this situation equals the change in the dependent variable, which is distance. So change in distance divided by change in time. Okay, that's how you figure out the rate of change. Now, to figure out if the rate of change is constant, the change from this ordered pair to this ordered pair needs to be the same change as from this middle one to this one. Then it needs to be the change same as the third one to the fourth one. Okay, so let's figure out all of those. So the rate of change, if I erase all this, the rate of change between the first two ordered pairs. Okay, so we're going to take the difference in the distance. So 520 minus, because it's the change, so we want to find the difference, 520 minus 260 divided by the change in the independent variable, time, which would be 2 minus 1. Okay, so 520 minus 260 is 260. 2 minus 1 is 1. 260 divided by 1 is 260. Okay, so the rate of change from the first minute to the second minute, this changed by 260. Okay, then we check the next one. So from 520 to 780, we take 780 minus 520. You always want to take the bigger number minus the smaller number so you don't get negatives. Divide it by 3 minus 2. Okay, so we have 260 again, divided by 1, which is 260. So it's constant so far, and then when we check the last one, the change from 1040 minus 780 over 4 minus 3. Now, just so you know, see how I have the 1040 first? I have to have the 4 first. And if I have the 780 second, I have to have the 3 second because they match together. So this is 260 over 1, which is again 260. Okay, so the question said, is the rate of change in distance with respect to time constant? Well, yes, it's constant because it's changing by 260 each time. And then it says, what does the rate of change represent? Well, what it represents is, and I'll have to make this smaller so I can write here. What it represents is that the band, if the rate of change is 260, then the band is marching 260 feet per minute. Okay, that's what the rate of change represents. And you might have learned last year about unit rate. This is a unit rate. If it's per minute, it's a unit rate. Right here, we're doing 520 feet per 2 minutes. Okay, but the unit rate is 260 feet per minute. Okay, so that's rate of change. Now, they graphed this on the next page, and I just want to point out to you that when the rate of change is constant, in most of this chapter it's going to be constant because rate of change isn't that important. What's important is slope here, and when you have a rate of change that's constant, it's going to make a straight line. It's going to be a linear relationship, and then we can figure out the slope of this linear relationship. Okay, so rate of change is like a tiny, tiny bit. Slope is huge in this chapter. So if the rate of change is constant, then it makes a straight line, and then we could figure out the slope. Okay, so the next vocabulary is slope, which is just the vertical change, which the vertical axis is the y-axis, divided by the horizontal change, which is the x-axis, which is the exact same thing as rate of change, but this is what you really want to focus on. This right here, rise over run. Like, you need to have that memorized, like, as quick as you can have that memorized. Slope is equal to rise over run. And the more we do this, and we will do this a lot, I'm sure if you're practicing and practicing, you will get it memorized. But we usually don't say vertical change over horizontal change too much, except when we're relating it to rate of change. We're more likely going to say rise over run. Okay, so right here it says, what is the slope of each line? So we have this dark black line, and I took this from the book. That's why it has all this extra stuff. But all you do is pick 2 points on the graph. Okay, so they picked this point right here in blue and this point right here in blue. To figure out the slope, you just need to calculate rise over run by counting the blocks. So if we just focus on this first one, count the blocks. So from this blue dot, you went up 1 block, 2 blocks. Okay, so your rise is 2. And then your run is from here, you went over 1, 2, 3. Okay, so you went up 2, over 3. So your slope is 2 over 3. And it's positive because it's going uphill. Okay, this one, part B, now the slope is going downhill. You always want to think of your slope as going from left to right. So this is going downhill, and we'll practice with that more, but pick 2 dots. So we have this dot right here, and we have this dot right here. Okay, this time, to go from the dot on the left to the dot on the right, we need to go down. So rise can either be up or down. Run always goes from left to right, just so that we have a standard, but rise can go up or down. So we're going down 1, 2, 3, 4. So our rise is -4 because we're going down 4, and our run is 1, 2, 3, 4, 5. Okay, so our slope, should be -4 over 5 because we went down 4 blocks over 5 blocks. And again, that would be the same thing, the rate of change. Now, these two graphs don't come from a real-life situation like the one with the marching band, but when we start putting them with situations, that's all that slope is. Slope is just the same thing as rate of change. Okay, then there's also a slope formula, because sometimes if they give you a graph, so I would write this down, and underneath rise over run, I would write graph. Because if they give you a graph, the easiest way to find slope is just counting the blocks. If they don't give you a graph, if they give you ordered pairs, you're going to have to use this formula. Okay? And it's the change in the y values. So y2 minus y1. divided by x2 minus x1. And I'll show you what that means, but just make sure you have all of that copied down. Okay, so what is the slope of the line through these two ordered pairs? Okay, so if we have the ordered pair -1, 0, and 3, -2. Alright, now, I'm only doing one of these. We're going to do a whole bunch in class, so it takes time. You might not get it this first time, but this is just like an introduction. Okay, so here's your formula down here. y2 minus y1 over x2 minus x1. Okay, how we get those values, this right here is your first ordered pair. So this is ordered pair number 1, and this is ordered pair number 2. Every ordered pair, the first number is your x value, and the second number is your y value. So this is x value number 1, this is y value number 1, because they both came from ordered pair number 1. This ordered pair number 2, this is going to be x value number 2, and y value, that looks like an x, y value number 2. Okay, then you just take those numbers and you substitute them into the formula. So if the formula is y2, that's this, -2, minus y1, that's 0, divided by x2, that's 3, minus x1, that's -1. Now, you have a minus in the formula and you're subtracting a negative, so make sure you put minus a negative. Okay, so -2 minus 0 is -2, and then 3 minus -1 changes to plus, so that 3 minus -1 is 4. Now, simplify if you can, so -2 over 4 simplifies to -1/2. So the slope of the line between those 2 points is -1/2. And again, we are going to practice that so many times you'll get the hang of it. But watch it again if you need to figure out like what x1, y1 is, and get this formula right here memorized as soon as you can. Okay, two last pieces. We have, you use those formulas, we use those formulas for all of them, but they're special cases. So if you have this red line right here, obviously the slope is 0. It's a flat line. So when you plug in these ordered pairs, and they just pick 2 ordered pairs, we can kind of skip ahead. You know, you plug them in, and you get something like this. 0 divided by 5. Well, 0 divided by anything is 0. So anytime you have a horizontal line, you should be able to look at the line and say that the slope is 0 because it's flat. But they're not always going to give you a line. Sometimes they're just going to give you the ordered pairs. So if they give you the ordered pairs and you end up getting 0, that just means that you have a flat line. Okay, the other case is if you have a vertical line. Okay, so what happens when you have a vertical line is you get something like this, 3 divided by 0. Now you're not allowed to divide by 0 because it's just, you're not allowed to divide by 0. So what they say is the slope of a vertical line is undefined. Okay, it's not 0, it actually has a specific vocabulary term called undefined. And the reason that it's undefined is because this isn't a function. This fails the vertical line test. So you can't have a slope if you don't even have a function. Okay, so you can have a vertical line and it can be a relation and you can have ordered pairs, but it's not a function, so the slope there is undefined. Okay, so if you see the vertical line on a graph, just look at it and see that it's straight up and down, say undefined. But if they give you 2 ordered pairs and you don't have the picture, you might be able to tell if the x values are the same. It's going to be undefined because you know that it's not a function. But if you plug it into the formula and you're dividing by 0, you can't do that, so you would just say undefined. Okay. I think page 297 does a really good job of kind of summing everything up in the key concepts box. So I didn't want to copy and paste it into here, but if you want to take some time and copy that into your notes, it does a really good job of summarizing like positive slopes and then like those last 2 things we just went over. So I would copy down that and work on those 7 problems in the lesson check. We'll start with them. We'll go over them at the beginning of class tomorrow.